So it's a 7-factor quadratic-like polynomials. Over on the right side here, I have the steps to factor. First thing would be to divide out its greatest common factor if you have the greatest common factor. We look at the first three terms, or all three terms, see if there's something we can divide out of it. There's not anything that we can divide out all three terms. So then we skip that step in this case. We do step 2, which is a times c. This is, I guess we should talk a little bit about quadratic-like polynomials. Quadratic-like is ax squared plus bx plus c. So this is where we're going to get our a and c and eventually our b from. So we have a times c, so that's 4 times negative 2, so negative 8. And we're looking at what two numbers multiply to negative 8. So I'll put a negative 8 in this. X is kind of a graphic organizer for us. Two numbers multiply to negative 8 that will also add up to the b, which is negative 7. So we're looking for two numbers that multiply to negative 8 that adds up to negative 7. Those happen to be negative 8 and positive 1. Those will multiply to negative 8, they'll add up to negative 7. Now we're going to take our b term, and we're going to split it up into negative 8, x squared and 1x squared. So 4x squared minus 8x squared plus 1x squared minus 2. So now we're at step 3. Step 4 is split up. Step 5 is group the first and last two terms. So first two terms, last two terms, grouping them. Step 6, find the greatest common factor for the first and last group. So step 6, greatest common factor between the first two terms is 4x. This was step 4. So it should be 4x squared is your greatest common factor. So we're going to divide out with 4x squared out of both terms. So that'll be x squared minus 2. Greatest common factor of the second two terms is just 1. So we're going to divide a 1 out. And the last thing we do is we're going to regroup. We're going to look at what you have in parentheses. It's exactly the same. That's one of your factors. And on the outside, your greatest common factor, just put those together, and that's your second factor. Look to see if you could factor either one of the binomials further. We can't. We'll talk a little bit more about that later. Looking at the second example, we have factoring completely. Here we have x's and y's. Don't let it trick you. It's very, very similar to what we did with this last problem, where it's ax squared plus bx plus c. There's three terms. It's, in this case, it is a quadratic. So we're going to look again, a times c first. So our a times c is 6 times negative 15. That's negative 90. And what two numbers multiply to negative 90? That'll add up to the b term, negative 1. Those two terms are going to be, there's two numbers that are negative 10 and positive 9. We're going to take those two terms and we're going to split up the middle term here, the b term. We have 6x squared minus 10xy plus 9xy minus 15y squared. So we look, middle term, we split it up into two terms. The reason why we do this is the next step is to group the first two terms and the last two terms. And we take out our greatest common factor of the first two terms. So the first two terms here, greatest common factor should be 2x. So we're going to, it's like you're undistributing the 2x. So by the first two terms, or first term by 2x, you get 3x. Last term by 2x, you get 5y. The second grouping, the greatest common factor is 3y. So we're going to, it's a positive 3y. By the first term by 3y, you get 3x. Second term by 3y, you get minus 5y. What's inside has to be exactly the same. That binomials, they're the same. That's one of your factors, 3x minus 5y. If they're not the same, then you either did something wrong or the problem's not factorable. On the outside, your greatest common factors, you put them together, and that's your second binomial factor. And our last example today will be, so this is similar to our last problem, except now it's 4 terms. 4 terms, this is we're jumping right to grouping. Anytime you see 4 terms, let's just group it right away. And we look for the greatest common factor. So we're jumping right to step 5. We're going to be right at step 5 where we're regrouping it. Look up for your greatest common factor. Greatest common factor is x squared of the first 2 terms. Divide the first term by x squared. Divide the second term by x squared. Of the second 2 terms, the greatest common factor is 4. If the first term is negative, always take a negative with the greatest common factor. So negative 4. Divide the first term by negative 4, you get x. Divide 20 divided by negative 4 is negative 5. What's in parentheses has got to be the same. It is. That's one of your factors. What's on the outside? Your greatest common factors, put that together as your other factor. Now, saying it's completely, factor completely is not quite right here. It's not done yet. You look at each individual term or a factor and see if you can factor it further. If there's the greatest common factor, or if it's, in this case, a perfect square binomial. You can ever see that you have a subtraction in the middle, and you can square root both terms. So a subtraction, and you could square root both terms. You can actually do, so square root of x is x. Square root of 4 is 2. One of the operations is addition, one subtraction. So x squared minus 4 actually gets factored into x plus 2, x minus 2. And then we have the x minus 5 that will come down. We'll work more with this in class. That is 7b.